Hello students, in this video we are going to discuss about basic mathematics which are necessary for learning physics. In this session we are going to cover elementary algebra, trigonometry, coordinate geometry and then calculus. Let us get started with elementary algebra. And here I have provided some basic formulas which we frequently use in our physics. Take a look at this and then we'll move on to next slide. Here we'll discuss about types of equations which are polynomial, linear and quadratic equations. So, what is a polynomial equation? The first condition to say it's a polynomial is that the highest power of the variable is non-negative integer. So, here I have provided one example. In this, you can check that the highest power is non-negative integer. Okay, so the first condition is satisfied. So, we can say this is a polynomial. And let us verify second and third conditions also. The second condition says that the coefficients of the variable are constant numbers. So here the variable is x, the coefficient of x is 3 and x square is 1. So these are the constant numbers. So second condition is also verified. Now let us look at the third condition. Finally, the equation is set equal to 0. Then this is said to be a polynomial equation. Okay. Now, what about degree of a polynomial? How we can define degree? Degree is the highest power appearing in a polynomial. So here I have provided this one more example. F of x is equal to x cube plus 8x plus 3. In this, the highest power appearing is 3. So the degree of this polynomial is 3. Okay. So I have provided one more example here. Here the function is based on two variables x and y. So this function is what? F of x comma y is equal to 3x square y plus y square plus 2. So look at this term here, 3x square y. Here both variables x and y are part of same term. So here power of x is 2 and power of y is 1. So the total power is 2 plus 1. So here the degree is also 3. Okay. So 3x square y, the degree is 3 because here these two powers will get added. Now I hope you have got an idea about the degree of a polynomial. Let us move on to next slide. Here next one is linear equation. Equations having terms of unit degree are called linear equations. Earlier we have seen what is a degree. Degree is what? It is the highest power appearing in a polynomial. Now in a linear equation, the highest power appearing is only 1. Okay, such equations are called linear equations. Equations with unit degree are called linear equations. Here I have provided two examples for linear equations. For such equations, if we plot the graph, it is always a straight line. That's why the name here linear. Okay, if you plot the graph for such linear equations, it is always a straight line. We will learn about plotting the graphs in the upcoming videos. Next one is quadratic equations. Equations of second degree are called quadratic equations. So here I have provided an example. Suppose a polynomial is written as ax square plus bx plus c is equal to 0, where a is not equal to 0. So here the degree is 2. That is, the order of the degree is 2, which is called second order degree. Now, roots of quadratic equation. What is meant by root? Root is a solution of quadratic equation, which means if suppose you got x, after solving for roots you got x value, suppose 2. If you substitute this 2 here, you should get a answer 0. So if not, 2 is not a root. So to find out such roots, we have formulas here. First root alpha is equal to minus b plus root over b square minus 4ac. upon 2a. Second root is minus b minus root over b square minus 4ac upon 2a. So let us take one example to find out the roots and let us verify whether those roots are solutions of given equation or not. Let us take one example, which is x square plus 3x plus 2. Okay. Now let us find the roots of this equation. First root is what? Alpha equal to minus b plus root over b square minus 4ac upon 2. Okay. So here the coefficient of x square is 1, which I can take it as a. The coefficient of x is 3, I can take it as b, and constant I can take it as c, because it is in the form ax square plus bx plus c is equal to 0. I can compare these coefficients. Here in the given example, the 1 is in the place of a, 3 is in the place of b, 2 is in the place of constant c. Now let us put these values in this equation. Now alpha is equal to minus b. Minus b means minus 3 plus root over b square. B square means what? Here b square means in place of b, let us substitute value b, which is 3 square minus 4 into a. In place of a we have 1 and c we have 2. Whole divided by 2 into a. A is what? 1. So let us simplify this one. Minus 3 plus of root over 3 square means 9 minus 4 into 1 into 2, it is 8. Whole divided by 2. So if you simplify this one, we get minus 3 plus root 1. Root 1 means 1. Whole divided by 2. Now finally the alpha value we get minus 2 divided by 2, which is minus 1. So this is the first root, means first solution of the equation. Next let us calculate second root, which is beta. The beta is given as minus b minus root over b square minus 4ac whole divided by 2a. Okay. Now what is beta here? Minus b. Minus b means minus 3 minus root over 3 square minus 4 into a. A is what? 1. C is what? 2 divided by 2 into 1. So this you will get minus 3 minus of root over 9 minus 8, which is 1. Okay, whole divided by 2. So this will give you minus 4 by 2, that is minus 2. This is second root. This is our second root. Now we have two solutions. Let us put these values in the given polynomial. Let us verify these roots are correct or not. Okay, so in the given equation, x square plus 3x plus 2 is equal to 0. Put the value minus 1 in place of x. So minus 1 whole square plus 3 times of minus 1 plus 2. Let us verify if it is equal to 0 or not. Minus 1 whole square, 1 minus 3 plus 2, which is minus 3 plus 3. So that is equal to 0. So this is alpha equal to minus 1 is our first root. Now let us verify with minus 2. Let us take the polynomial again. X square plus 3x plus 2. Now substitute minus 2 in place of x, which is minus 2 whole square plus of 3 into minus 2 plus 2. So minus 2 whole square is 4 minus 6 plus 2. So this again gives us a 4 plus 2 6, and this is minus 6, which will give us 0. Okay. So this is how you find the roots of given polynomial. I hope you understood. Next, move on to next slide. Here is the very important topic, elementary trigonometry. So here we don't discuss about all the things in trigonometry. We'll discuss about what are the necessary things for. So here we don't discuss all the things in the trigonometry. We will discuss whichever are necessary for learning physics. Okay. So first, what is the basic purpose of trigonometry? In this trigonometry, we measure the sides of the triangle. There are some more applications of trigonometry, but basically we deal with the sides of a right angle, triangle, or any other triangle. Basically, we deal with the sides of a triangle and the angles associated with it. Okay. Now, let us discuss about the angle first. In angle, there are two types: positive angle and a negative angle. So, what is a positive angle? Suppose I take this line as a reference line. Now, suppose this line is moved from here to here in anti-clockwise fashion. Anti-clockwise fashion. This line has been moved to here in a anti-clockwise fashion. Then the angle subtended by this line is said to be positive. Similarly, if you take this as a reference line, now this line moves in clockwise fashion and comes over here, then this angle subtended is negative. This angle is negative. Okay. So thing to remember is the angle which is subtended in anti-clockwise fashion is positive. The angle which is subtended in in clockwise fashion is a negative. Okay. Remember these 2 points. Now, since theta is a physical quantity which can be measured, it should have some units, right? So the theta is measured in several units, namely degrees, radians, minutes, and seconds. Okay. So these degrees and radians are the units which we frequently use for measuring theta. Okay. So here the formula for theta is arc length upon radius. Arc length upon radius. What is arc length? Suppose a particle is here at P and it moves to point Q along this perimeter of the circle. So this is what called arc length L. Okay, and this line is called radius. From center to point P, this line is called radius. Now, what is the value of angle subtended? The value of angle subtended is theta is equal to arc length upon radius, which is L by R. Okay. Now, since length has unit meters and radius also has unit meters, they get cancelled. So theta doesn't have any dimension. Theta doesn't have any dimension. It has unit. Theta has unit. Degrees, radians, minutes, seconds. It has unit, but it doesn't have any dimension because it is a ratio of same quantities. Length is in meters, radius is in meters. So since it is a ratio of same quantities, it doesn't have dimension, but it has unit. Remember this point. Next, here out of degrees and radians, radian we use frequently. So let us learn one more point about the radian. What exactly is 1 radian? What exactly is 1 radian? 1 radian is the angle subtended when the particle covers arc length, which is exactly equal to radius of that circle. Okay, if arc length L is equal to radius of that circle, then angle subtended is 1 radian. How many such radians are there in the circle? There are 2 pi radians in one circle. Okay, and we already know that in a circle there are 360 degrees. Then what is the relation between degrees and radians? In one circle there are 2 pi radians and 360 degrees. That means 2 pi radians is equal to 360 degrees. Then what about pi radians? In order to find pi radians, bring this 2 over here and this becomes 360 by 2, which is 180 degrees. That means pi radians is equal to 180 degrees. And then what is 1 radian? Bring this pi over here, we'll get a 1 radian is equal to 180 by pi. Okay, which is equal to 57.32 degrees. If you put the value of pi, which is 3.14, you will get a 57.32 degrees. Now we have 1 radian. Then what about 1 degree? We should know the other way around also. We know 1 radian equal to 180 by pi degrees. Then what is 1 degree? It is the reciprocal of earlier one. Okay, so 1 degree is pi by 180 radian. These conversions you definitely remember. 1 radian is equal to 180 by pi degrees, and 1 degree is equal to pi by 180 radians. These conversion factors you must remember. Okay, now let us learn about the other units of degree, which are minutes and seconds. Here I will take 1 degree out of 360 degrees in the circle. Okay, so let us suppose this represent 1 degree. Now this 1 degree I am further dividing into 60 parts. Here I cannot draw all the 60 parts, but assume these are all the 60 parts of that 1 degree. Okay, now in 1 degree there are 60 minutes. Each division of this 1 degree represent 1 minute. So how many such divisions are there? In 1 degree there are 60 divisions. Each division is a minute, and then 1 degree contains 60 minutes. Okay, now let us divide 1 minute into 60 parts again. Earlier what we have done? We have divided 1 degree into 60 parts. Now let us divide 1 minute into 60 parts again. So in this 1 minute again there are 60 divisions. Each division represent 1 second. That means in 1 minute there are 60 seconds. Minute is represented by prime and second is represented by double prime. Okay, now we have to make a note that the formula theta equal to L by R, L and R should have same units. If L is mentioned in centimeters, R also should be mentioned in centimeters only. Or if L is mentioned in meters, R also should be mentioned in meters only. That means both L and R should be having same units. Then the theta is measured in radians. In this formula theta equal to L by R, remember theta is always in radians only. Okay, if it is given in degrees, suppose in any problem it is given in degrees, you convert that to radians using these conversion factors, then use that equation. Next one, trigonometric ratios. Here if you look at this right angle triangle, these ratios are for right angle triangle. Okay, if you look at this right angle triangle, here we have adjacent side. Whichever side is adjacent to this theta is called adjacent side. Whichever side is opposite to this theta is called opposite side, and the longest side of the triangle is called hypotenuse. These things you already know. Now, what are trigonometric ratios? Ratios means if suppose we know angle theta and we want to find adjacent side knowing one of the other sides. That means suppose you know value of theta and you have opposite side and you want to find adjacent side. How you can find? Using these ratios you can find such values. Out of these four unknowns, hypotenuse, opposite, adjacent, theta, out of these four unknowns, if you know any two of them, you can find the rest of the unknowns. Okay, using these ratios. The ratios are sine, in short sine, cosine, in short cos, tangent, in short tan, cosecant, in short cosec, secant, in short sec, cotangent, in short cot. Okay, so the last three ratios are reciprocals of first three ratios. Okay, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotan is the reciprocal of tan. Okay, now let us learn how to deal with this. Now the ratio, trigonometric ratio sin theta is given as a opposite side upon hypotenuse. Cos theta is given as a adjacent side upon hypotenuse. Tan theta is given as a opposite side upon adjacent side. To remember this, I have highlighted the first letters SOH. So CAH, Ka, TOA, TOA. So if you remember this, so Ka, TOA, You can remember these formulas. Okay. Now, what about remaining trigonometry ratios? As I said, cosecant theta is the reciprocal of sin theta. Secant theta is the reciprocal of cos theta. Cot theta is the reciprocal of tan theta. Okay. Now, here I have provided some basic angles that we deal with frequently. Okay. Those angles are 0 degrees, 30 degrees, 45, 60, 90. And corresponding angle is given in radians also. 0 degrees in radians is 0 radians. 30 degrees in radians is pi by 6. 45 degrees in radians is pi by 4. 60 degrees in radians is pi by 3. 90 degrees in radians is pi by 2. So let us take one value and convert that into radians so that you will understand why these values are written here. Okay. So we know that 1 degree is equal to, earlier we have seen a conversion factor, 1 degree is equal to pi by 180 radians. 1 degree is equal to pi by 180 radians. Then what is 45 degrees? If 1 degree is pi by 180, then 45 degrees is 45 into pi by 180 radians. So 45 and 180 4 times. Okay, which is pi by 4 radians. That means 45 degrees is similar to pi by 4 radians. Okay, that's why 45 degrees means I have written in a radians as pi by 4. Okay, now how to use this table? Now in this table, if you see sine 0, sine the angle is 0, sine 0 is what? 0. Next sine 30, sine 30 is what? 1 by 2. Next sine 45, sine 45 is what? 1 by root 2. Sine 60, sine 60 is what? Root 3 by 2. Sine 90 is what? 1. Similarly, cos 0, cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2, cos 90 is 0. Okay. So what about tan then? Tan is what? Sin upon cos. So 0 by 1 is 0, 1 by 2 by root 3 by 2 is 1 by root 3, 1 by root 2 upon 1 by root 2 is 1, and then root 3 by 2 upon 1 by 2 is root 3, and finally 1 by 0 is undefined actually, but in some numericals we use this tan 90 as infinity. Okay, let's move on to next slide. Other than 0, 30, 45, 60 and 90 degrees, we have another important angles 53 and 37. Okay, to deal with these angles, first we have to look at this 3, 4, 5 triangle. 3, 4, 5 triangle. Okay, now suppose this side is 3 and this side is 4. Using Pythagoras theorem, we can find the hypotenuse as a 5. Okay, so this 3, 4, 5 triangle is very, very important. Here, let us find sine 53. How do you find sine 53? Sine is what? Opposite by hypotenuse. So here opposite is 4, hypotenuse is 5. So therefore, sine 53 value is 4 by 5. Next, cos 53. What is cos 53? Cos is adjacent side upon hypotenuse, which is 3 upon 5. Next, sine 37. Sine 37 is what? Again, opposite upon hypotenuse. For 37, what is the opposite side? 3. So, here it is 3 by hypotenuse is 5. Now, cos 37. For 37, what is adjacent side? 4 is adjacent side for 37. So, it is 4 upon hypotenuse 5. If you look at these values, sine 53 and cos 37 having same values, and cos 53 and sine 37 having same values. Okay. Now, so far we have seen the common angles 0, 30, 45, 60, 90 degrees, and also 37 degrees and 53 degrees. Now, what about the other angles like 270 degrees, 150, 150 degrees, and also 270 degrees? How to deal with such angles? Now, here to calculate a sine 270 or sine 150, for such values we have to look at the quadrant method. So let us suppose a circle is divided into 4 quadrants. A circle has 360 degrees. So let us divide each quadrant into 90 degrees. 90, 90, 90, 90, total 360 degrees. Okay. The first quadrant spans about 0 to 90 degrees. Second quadrant is from 90 degrees to 180 degrees. Third quadrant 180 to 270 degrees. Fourth quadrant 270 to 360 degrees. Okay. In the first quadrant, all the trigonometric ratios are positive. That means sine, cos, tan, cosecant, secant, cot, all are positive. In second quadrant, only sine and cosecant are positive. In third quadrant, tan and cotan are positive, and rest of the ratios are negative. In fourth quadrant, cos, secant are positive, and rest of the ratios are negative. Here, why sine and cosecant only? Because cosecant is the reciprocal of sine, cot is the reciprocal of tan, secant is the reciprocal of cos. Okay, so sine and its reciprocal are positive, tan and its reciprocal are positive, cos and its reciprocal are positive. Rest of the ratios are negative in these given quadrants. Okay, now let us find the value of sine 270. When such values are given, we have to split this angle into two parts. Okay, remember before splitting, we have to make use of 90, 180, 360. Commonly, we split angle with a combination of these angles 90, 180, and 360. Okay, you can use 270 also, but commonly we use 90, 180, and 360. Okay, now sine 270 can be split as a sine of 180 plus 90 degrees, isn't it? Now this sums up to 270 only, no? Now sine 180 plus 90. Okay, so 180 plus 90 means which quadrant? 180 plus theta. That means it lies in a third quadrant. Sine 180 plus 90 lies in a third quadrant. Remember, whenever the angle is a combination of even number here, 180 plus 90. So here 18 is a even number. The sign remains a sign only. These are the shortcuts to remember. Whenever the combination is written with a even number, 180 plus 90. Here 18 is a even. Sign remains sign only. No change in this. Okay. Now what is the angle here? 90. Now question is it positive or negative? Okay. So sine 180 plus 90 is in the third quadrant. In third quadrant, only tan and cot are positive, remaining all are negative. So here you get a negative value. So what is sine 90? 1, but the sign is minus 1. So the value of sine 270 is minus 1. Now let us find out sine 150. How you can write a sine 150? Sine 150 can be splitted as a sine of 90 plus 60. Isn't it? Sine 90 plus 60. Now check 90 plus 60 is which quadrant? 90 plus theta is a second quadrant. In second quadrant, sign positive only. So write positive. And here comes the odd combination. 90 is a odd number. Now it is a odd number. Sine 90. Whenever odd number comes here, sign changes into cos. Okay. Now what is the angle here? 60. So cos 60 is how much? 1 by 2. So the value of sine 150 is 1 by 2. Similarly, tan 150. So let us write tan 150 with a combination 90 plus 60. Okay. So here comes 90 which is odd. So tan becomes cot and the angle is 60. 90 plus theta, which quadrant? Second quadrant. In second quadrant, tan is negative. So here put negative minus cot 60. So cot 60 is the reciprocal of tan 60, isn't it? So in this table, find for tan 60, which is root 3, and the reciprocal of this is 1 by root 3. Okay. Here is a minus and I put minus here. So tan 150 is minus 1 by root 3. In the same way, you can find the value of cos 270. Okay, now let's move on to next slide. Here let us plot the graphs for sine function and cosine function. These sine function and cosine function are periodic functions. Why they are periodic functions you will understand after plotting this graph. Okay, so for plotting graph we need x coordinate and a y coordinate, isn't it? So on x axis let us take the angle theta. On x axis take angle theta, and on y axis take the value of sine theta. Okay, now first let us start with 0. When theta is 0, sine value is also 0. When theta is pi by 2, sine value is 1. When theta is pi, sine value is 0 again. When theta is 3 pi by 2, sine value is minus 1. Okay, when theta is 2 pi, its value is 0. Okay, so plot the graph for these corresponding values. Now 0 comma 0, 0 comma 0 starts here. Okay, next pi by 2 comma 1, pi by 2 comma 1. So here is pi by 2 and here is a 1, pi by 2 comma 1. Now third coordinate is pi comma 0. Here is pi comma 0. X coordinate is pi, y coordinate is 0. Next 3 pi by 2 comma minus 1. Here is 3 pi by 2 and here is a minus 1. 3 pi by 2 comma minus 1. Okay, next last coordinate 2 pi comma 0. So here is a 2 pi comma 0. So if you join all these points we get a waveform. If you extend this one further this is how you get the wave. Okay, now why it is called a periodic function? See, sine value is 0 when the angle is 0. When this angle is repeated again after 2 pi, same situation is repeated again. Okay, sine 0 is 0 and sine 2 pi is also 0. So after every 2 pi its value repeats. If you continue this waveform like this, after every 2 pi interval the sine values will repeat. Okay, that is why sine function is a periodic function. Next, look at cosine function. Do the same thing. Take angle on x-axis, cos value on y-axis, and plot a graph for these corresponding coordinates. Okay. Here also, if you look at the first coordinate, x value 0, the angle cos of 0 is 1, 0 comma 1. Second angle is pi by 2. So for pi by 2, the cos value is 0, pi by 2 comma 0, and here it is a pi. For pi the cos value is minus 1, pi comma minus 1, and 3 pi by 2. For angle 3 pi by 2 the value is 0. For angle 3 pi by 2 the cos angle is 0. For 2 pi the cos value is 1. So at 2 pi the cos value is a 1. Now if you join all these points the waveform looks like this. Here we have started with angle 0, then we got cos value 1. When it is repeated again, it is repeated again exactly after 2 pi interval. Okay, so initially cos value is 1 at 0 degrees, and again cos value is 1 at 2 pi, angle 2 pi radians. Okay, so this is also periodic function because it has interval of 2 pi radians. Cos values repeat after every 2 pi interval. Okay, that's why cosine function is also a periodic function. Now these are the common formulas we use in trigonometry. Very very important, make a note of it. Sin a plus b, sin a minus b, cos a plus b, all these formulas we frequently use. And sin square theta plus cos square theta is equal to 1. These also we frequently use in our physics. Okay, and sin c plus sin d is 2 sin c plus d by 2 into cos c minus d by 2. Okay, make a note of all these formulas. Now we will see how to make use of all these formulas. So suppose we have sine 15 degrees. So far we have seen common angles 0, 30, 45, 60, 90, 37 degrees and 53 degrees. Then how to deal with such angles, sine 15 degrees. Earlier we have seen sine 270. If sine 270 is given, what you will do? You can split this into sine 180 plus 90 degrees. And you did the quadrant method. Okay. So here can you do like that? Here it becomes little complex. So we don't go for a quadrant method. We go for formulas that we have seen here. Okay. Now sine 15 can be written as sine of 60 minus 45. Any whichever combination that will bring out this value, you can use that. I am using here 60 and 45 to bring a result 15 degrees. Okay. So sine 60 minus 45 is in the form of sine a minus b. What is the formula for sine a minus b? Sine a minus b is sine a cos b minus cos a sine b. So here the formula can be written as sine a. Okay, it can be written as 30 plus 45. No, it can be written as 30 plus 45. So this angle can be written as sine of 30 plus 45. So here a is 30, b is 45. Now it is in the form of sine a plus b. What's the formula for sine a plus b? Sine a plus b is sine a cos b plus cos a sine b. Sine a cos b plus cos a sine b. Okay. What is the value of sine 30? It is 1 by 2. What is cos 45? It is 1 by root 2 plus what is cos 30? Cos 30 is root 3 by 2 multiplied by sine 45 is 1 by root 2. So if you simplify this, in the first term the denominator is 2 root 2 and numerator is 1 plus the second term it is 2 root 2 and numerator is root 3. So it gives you 1 plus root 3 by 2 root 2. So what is the value of sine 75 degrees? Sine 75 degrees is 1 plus root 3 by 2 root 2. Similarly, you can find the values of cos 120 and sine 405. Take it as assignment, you can solve for that. Okay. Now, what about the negative angles? So far we have seen all the positive angles only. Now, what about negative angles? Here, sine of minus theta is minus sine theta. Cos of minus theta is plus cos theta. Tan of minus theta is minus tan theta. Cosecant of minus theta is minus cosecant theta. Secant of minus theta is plus secant theta. Cot of minus theta is minus cot theta. Here all of them are negative only except for cos and secant. Even though angle is negative, cos theta is plus cos theta only. Secant is plus secant theta only. So we will see why it is that. It is like that. Okay. So to verify that we need a unit circle. Unit circle means what? It has radius 1 unit. Okay. Unit circle has radius 1 unit. Okay. Now let us see how we can verify why cos of minus theta is plus cos theta. Okay. So let us draw a unit circle over here and the radius of it is 1 unit. Okay. Now suppose it subtends an angle theta. This line subtends an angle theta. Okay. Now at this point, what are the coordinates? If radius is 1, let us write the coordinates of this point. Okay. X comma y. What are the coordinates at this point? Now suppose this is the line that is making angle theta with the x-axis or horizontal line. Now I would like to find how much is its height, which is y value, how much is its base, which is x value. How we can find that? Here we can make use of the trigonometric ratios. I know theta value and I want a y value. Okay, and I know hypotenuse. Okay, so out of these three, theta, y, and 1, using these three, I can find the value of y. How I can find? Y is the opposite side here. So opposite side of theta and I know hypotenuse. So what ratio I can use? It is obviously sine theta. Sine theta is what? Opposite by hypotenuse. Opposite is what? Y. Hypotenuse is 1. So y is equal to 1 sine theta. Similarly, let us find for x. X is the adjacent side and I have hypotenuse and I know angle theta. Okay. So if you want to find adjacent side, what ratio you go for? I go for trigonometry ratio cos theta, which is adjacent side upon hypotenuse. Here adjacent side is x upon hypotenuse is 1. So x is equal to 1 cos theta. So here we got the coordinates 1 cos theta as x coordinate and 1 sin theta as a y coordinate. Now go back to previous slide. Here I have derived that the coordinates of this point are 1 cos theta and 1 sin theta. Now for this point to move from here to here, it subtends a positive angle. Okay. So when theta is positive, I got both the values positive only. Cos is positive, sin is also positive only. Okay. So the point to remember is whenever theta is positive, both sin and cos are positive only. Now, what if the angle is negative? What if theta is negative? That means now theta is going in a clockwise fashion. For anti-clockwise, the theta is positive. For clockwise, theta is negative. So whenever theta is negative, what about its cos and sin values? Do the same process as earlier. Find the coordinates of this point. Now the coordinates are 1 cos theta and minus 1 sin theta. Okay. So even though angle is negative, the cos value remains positive only, but the sin value becomes negative. This is the reason for negative angle sin is negative. For negative angle cos is positive. Hope you understood. Next, move on to next slide. Here we have another important formula which is called sine rule. Here I have provided the derivation of it. If you are interested, you can go through it. Otherwise, simply remember this formula. What's the advantage of sine rule? So far we have dealt about right angle triangle. The Pythagoras theorem can be applied to right angle triangle, and the above ratios. So far we have discussed all can be applied to right angle triangle, but this sine rule can be applied to any triangle. Okay. If it is not a right angle triangle, you want to deal with the sides and angles, the sine rule is helpful. Okay, you better memorize this. Similarly, we have cosine rule. This also for any type of triangle. Here cosine rule we have three formulas. Here also, if you know the sides and angles, you can deal with any kind of problems which are based on non-right angle triangle. You can make use of these three formulas. Okay, that's it for the day.